Okay, I got a 41 kilogram box sitting on the floor. Box, 41 kilograms. Guy exerts a force on it of 135 newtons. Horizontally. So we push on it here, 135 newtons. The coefficient is 0.25. How fast is the box accelerating? All right. What causes the box to move? A force will cause it to move, right? What kind of force? No, not a normal force. That shouldn't make it move. What? Not the applied force. I'm applying 135 newtons of force, right? Does all of that make that box move? No. Some of it's got to overcome the friction, right? Anything left over will cause it to accelerate. The net force. Net forces cause things to accelerate. Unbalanced force is another word that they use for net force. I know I'm applying 135 newtons of force. What other forces are acting on that box? Friction. Which way does friction act? Opposite of motion. So there's a force of friction going that way. How big is that force of friction? Well, the force of friction is the coefficient times the normal force. Because we got the force of gravity acting down, and we've got the normal force acting up. Normal forces, normal means perpendicular to the surface. So it's going to act perpendicular to the surface. In this case, the normal force equals the gravitational force. So the gravitational force would be 41 kilograms times 9.8 meters per second squared times the coefficient of 0.25. So my frictional force is how much? Because that's the only way to get force. You can't use mass. It's got to be force. Because when we went to the moon, it would take the mass times 9.8 is the weight. Mass is not weight. Mass times 9.8, or mass times acceleration gravity, is weight. Yep. The normal force equals the gravitational force in this case. So what's my frictional force? Doing it in my head, it's a little over 100. It's like 101, right? But you only got two significant digits, so how can you show two significant digits? That would be 3. 1.0 times 10 to the second would be the best way to show it. Again, what does your calculator tell you? 100.45? Like that? You only get two significant digits, 1, 2. We got to round off. If we write it as 100, that's only one significant figure. 1.0 times 10 to the second would be your best option. Again, on the quiz and stuff like that, that's gonna show up. 100 will be an option. 1.0 times 10 to the second will be an option. They're the same numerical value, but you've got to figure out significant digits. So that's my force of friction. Is the box going to move? That's my first question. Will the box move? Yes, because I'm exerting more force than the friction. What if the frictional force was 136 newtons? Then the box would not move. Makes the question easier to answer. So how much force is causing it to accelerate? 135 minus 100 is 35 newtons of force causing it to accelerate, which is then equal to ma. Mass times acceleration. Force is mass times acceleration. This is what's causing it to accelerate. So 35 divided by 41 equals its acceleration. 41 kilograms. This is what we're figuring out, how fast it's accelerating. How fast is it starting to move? So that's like what? 0.85 meters per second squared. Again, we've got two significant digits. Now, just as a little hint to you on significant digits, most problems have two. That's just the way it tends to work out. Very few problems will have 5, or none of them will have 10. 2 is normal. 2 or 3 is pretty much what you're going to be dealing with. Any questions on that one? So we had to deal with friction. We had to deal with, the net force. Well, let's take this problem, change it a little bit.